Q12, I'm going to have a go at some of these questions from exercise 8.4. Some people had some trouble with the later one, so I'm going to pick up from question 24 and work my way through 30. Make sure you have a go at them yourself first, though. So in question 24, I get told that the third term of a series is 45 and the ninth term is 75. Well, there are two ways to do this, and I'm going to do it the intuitive way to begin with. So I'm just going to go, well, there's the first term, there's the second term, and then I've got 45. That's a third term. Then I have the fourth, the fifth, the sixth, the seventh, the eighth, the ninth is 75. So if I intuitively go, well, 75 minus 45. 75 minus 45, well, that equals 30. And I've got to jump 1, 2, 3, 4, 5, 6 steps back to get there. Well, 30 divided by 6, that means each of these have got to be 5. So I've got my common difference. My common difference equals 5. And if I go back another 2 steps, 40, 35, that means my first term is 35. And then I can just go, well, what do I want to find? T of 50. And if I wanted to be really thinking, I could have just kept going. But anyway, 50 is too many. And that's A plus n minus 1 times D. And that gives me 35 plus 49 times 5. And if I grab my calculator, 35 plus 49 times 5, it's 280. So you can do these questions in that manner. However, I really believe that you should be using the algebra and being able to manipulate the algebra. So I'm going to do 24 using the algebra. So T of 3 equals 45. And T of 9 equals 75. Well, if I write the equation, A plus 3 minus 1D equals 45. A plus 2D equals 45. If I do it over here, I get A plus 9 minus 1D equals 75. A plus 8D equals 75. Now if I call this equation 1, and I call this equation 2, and I go equation 2 minus equation 1, well, the A's will cancel. I'll get 8D minus 2D, I'll get 6D. And I'll get 75 minus 45, I'll get 30, which is what we got when we did it earlier. So we get the common difference is equal to 5. And then I just sub that in, or sub that value in to equation number 1. And equation number 1 was A plus 2 times 5 equals 45. And I'll get A equals 35. And then I just do the substitution for T of 50, which is 35 plus 49 times 5. And that gives me 280. So either way is just as good to solve that one. Let's move on now to question 26. Now if I look at question 26, it's a show. Now Margaret does this a little bit differently to the way that I would do it. Personally, I would, well, I'll show you what I would do. So 26. What have we got to show? Log 5x squared, log 5x cubed. I'm going to show that soon. So I've got log base 5x plus log base 5x squared plus log base 5x cubed, and so on to log 5 to the n, x to the n. Now you need to remember to do it the way that I suggest you do it is to remember that you've got to know your log laws. So I'm just going to rewrite all of these, log 5x plus, I'm going to pull that 2 out the front because it's in the power and I can pull it out the front, plus 3 log 5x plus dot 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 n log 5x. Now I can now factorise out the log 5x. Now remember, log 5x is going to be a number of some type. They're going to give us a value for that. And then I've got a 1. I get a 1 from that, plus a 2, plus a 3, plus a 4, plus a dot dot, plus an n. And this is a series. It's a series where a is 1, d equals 1, and it goes up by 1s. It's just a counting series. Remember that this is going to be a value, and that's enough to prove it's a series. The other way is to show that between each term you have a common difference. So if I go t of 2 minus t of 1, I'll get log 5x squared minus log 5x. Pull the 2 out the front, and I'll get 2 log 5x's minus 1 log 5x, which will give me just 1 log x, 5x. And if I do the same, t3 minus t2, I'll get log 5x cubed minus log 5x squared. Pull the 3 out the front, I get 3 log 5x's minus 2 log 5x's, which gives me 1 log 5x, which says, well, these things have a common difference. And if they have a common difference, they're essentially an arithmetic series. Well, either way would be good. So let's do B. Find the 80th term. Okay. Well, you can just do it intuitively. You can say, well, look up here. This is T1, this is T2, this is T3, this will be Tn. So the 80th term, T of 80, will be log 5x to the 80, or 80 log 5x. If you wanted to use a formula, you could. You go, well, T of 80 equals a log 5x plus n minus 1, 79 log 5x, and you've got one of them plus another 79, so it gives you 80 log 5x. So we've proved that it's a series. We found the 80th term. Now it says it gives us this value for x. It says if x equals 4, evaluate the 10th term. If x equals 4, well, you could use a formula, but I'm going to jump straight to it. The 10th term is 10 log 5x, but it told me that x is going to equal 4, so you get 10 times log 5, 4, and we know from our change of base we're going to get 10 times, well, that's log 4 over log 5 of any base, and because I've typed log, that's just log to the base 10 on my calculator. So if I go 10 times log 4 divided by log 5, I get 8.6. which is the correct answer. Okay, let's have a look at question 28. Now, if you've done 26, you're going to see 28 is exactly the same, except my x is 2. Watch, I'll show you how we get that. So we've got log 2 to the 4 plus log 2 to the 8 plus log 2 to the 16 ... Now I'm not going to write log 2 to the... I'm not going to write the nth term yet. I'm just going to play with this a bit. Well, I know my powers of 2, and I know that's 2 squared. And I know my powers of 2, and I know that's 2 cubed. And I know that's my powers of 2, so I know that's 2 to the 4. So log to the n will be... it's a little bit harder here, because remember, this is the T1 and the power's 1 higher, T2 and the power's 1 higher, T3 and the power's 1 higher. So the nth term will be log 2 to the n plus 1. But I'm not concerned about that too much yet. So let's pull the powers down the front. So I can write that as 2 log 2 to the 2. And I can write that as 3 log 2 to the 2. And I can write that as 4 log 2 to the 2. Well, hold on a minute. Log 2 to the 2 is just log 2 divided by log 2. Well, that's just 1. So this is 2 plus 3 plus 4 plus ... all the way up to n plus 1. Now, the logs disappear when you pull them out like that. What have I got to show? What have I got to find? I've got to find the 25th term. I've just got to find the 25th term. And I already see it. T of n, if I use the formula a plus n minus 1 times d, well, the first term, a, there it is, and the common difference, that's my a, my common difference is 3 minus 2, that equals 1. So I get 2 plus, for t of 25, 24 times 1, which equals 26. I could have jumped to it though. Here's t of n, it's n plus 1. I could just go, well, t of n equals n plus 1. So t of 25 equals 25 plus 1, 26. All right. Question 30, last one. Which term is 213y of 28y, 33y, 38y? So here's 30. 28y plus 33y, 33, 38. 33y plus 38y. ... Well, I'm going to take the y out, and I'm just going to look at this series with the numbers 28 plus 33 plus 38. ... And this is a series here, and I'll just leave the y out the front. I don't have to consider that. You could do the 5y and do it all, but it's going to be much easier if we do this. And in this series, a equals 28 and d equals 5. So t of n equals 28 plus n minus 1 times 5. Now they want to find 213y. So I just want to find when t of n equals to 213. So 213 equals 28 plus n minus 1 times 5. So 213 minus 28, 213 minus 28 gives me hold on, 185. And that equals n minus 1 times 5. If I divide by the 5, I get 185 divided by 5. 37. 37 equals n minus 1. Therefore, the 38th term is the term I'm looking for. And I'm just checking the answer. There we go. That's the right one. Hopefully you're able to do these. They're not that hard. Remember, you can be a bit intuitive about, or you can use the formulas. You can see that there's some log laws that you need to remember, because they do quite often use log laws in these sorts of questions. Good luck.